Hey guys, welcome to Chapter 2, Descriptive Statistics, Tabular, and Graphical Methods, which is code for we're going to learn you some graphs. No. But on a serious note, we're essentially going to be covering, I guess, all the graphs and tables that we're going to encounter in this course. And yeah, this is going to be kind of a short video. Just a lot of description here. Not going to be a lot of interactiveness. There's not going to be any problems that I give you on this or anything to solve. We're just going to run through the notes, and then I'll let you guys ask me questions in the discussion boards if you have them. You've probably seen a lot of these graphs before. You may already know what some of them are. So if that's the case, great. But yeah, we'll just talk through it, and that's that. So I believe this is on the homework. I believe there are some stuff with stem and leaf displays and maybe contingency tables in the Connect homework. I haven't looked at that in a few days, so I really don't remember. But yeah, so chapter 1 and chapter 2 homework. But yeah, there is not going to be an associated worksheet with chapter 2 or review or anything like that. So the notes will be the notes and the PowerPoints will be the PowerPoints. So there you go. Okay, moving forward. So the chapter outline, graphically want to summarize qualitative and quantitative. We're going to look at dot plots, stem and leaves, contingency tables, which are going to be something that are very, very useful in chapter 4 and chapter 12, I believe. But they're going to be something that you're going to want to be familiar with and get comfortable with because it really brings, I don't know, I guess I'd just say it's a really intuitive way to use statistics and probabilities. So you want that. You'll notice that we skip 2.6. That's by design. And then we go into 2.7 into misleading graphs and charts. So with 2.1, graphically summarizing qualitative data. With qualitative data, we want to do a frequency distribution. The names are going to identify the different categories. So right now we have it looks like a survey of 50 college students, and what is your favorite pizza, or what is your pizza preference? And so then this is just the categorized, or the uncategorized data. Summary, or the data can be summarized in a frequency distribution. This is a frequency distribution. And frequency distribution is defined as a table that summarizes the number or frequency of items in each of several non-overlapping classes. So like when we have a data point here, somebody's preference isn't Papa John's and Little Caesars. It's all mutually exclusive, meaning you have to pick one. Okay, and so then this frequency table is how many Brunos do we have? How many Domino's do we have? How many Little Caesars do we have? That's that. So this is how we'll categorize our qualitative data. That's pretty self-explanatory. So we should find eight Brunos in this list, 2 Domino's on this list, 19 Papa John's, and so on and so forth. Next, we have the relative frequency and percentage frequency table. So this is just taking this last table, which I guess we have here. I put that there. And the relative frequency of a class is the frequency of the class over n. N is going to be the total number of people surveyed, the total number of pieces of data that you have. So the frequency is just going to be how frequent is it given the number 1, or given 100% or whatever. So this is how we compute that. It's just going to be the number over the total. So 8 over 50. This looks like it's going to be 2 over 50, so on and so forth. Okay, 2 over 50, 9 over 50, 19 over 50, 4 over 50, and 8 over 50. And it gives you these decimals, which then you can convert to percentages. And this is your frequency, your relative frequency and percentage frequency table. Pretty intuitive, right? From there, we could do a bar chart. A bar chart, also known as a bar graph, also known as a histogram. And you've probably seen this one place or another, or many places, or whatever. So I feel like we all know what a bar chart is. If you guys have any questions, give them to me. But the height is going to be based upon the number of the number of frequency of each piece. So Bruno's has a height of 8, Domino's 2, so on and so forth. Pie chart. So this is going to be based on the frequency of it, because the pie is going to contain 100%. And so we're taking this data that we have right here in the percentage frequency table, and we would put it into a pie chart. It's just another way to visually show it with the the measurements, the names of the restaurants, the different categories. Sorry, the different categories. I forgot the technical term for it. With the different categories right here. Next, this might be something that you haven't seen. So this is called the Pareto Chart. This is essentially a combination of a bar chart, a histogram, and a line chart. So a line chart is essentially the same thing as a bar chart, except you don't have bars. But the line chart, or the line graph, the height is based upon like the frequency. Okay. In this Pareto chart, you have a standard histogram, and then the line graph is the cumulative effect as you go out. So we're looking at this. We have crooked label, missing label, printing error, loose label. I'm not even sure what this data set is, but so crooked label accounts for 30, it looks like 36%, okay, 37%, and that's shown here in the bar chart. We have a different scale on the right hand side for the line graph, and if we show this portion of the line and drag it over, we're approximately at 37% here. Okay, we go to missing label. Missing label is 21.33%. Okay, tall. This dot on the line graph is going to be this 21.33 plus this 36.97 for a cumulative percent of 58.3. So it's just a running total of percent. So right here you have the standard histogram. Here you have the running total, and that's why it's always going to go up to 100%. Graphically summarizing quantitative data. Often we need to summarize and describe the shape of the distribution as well. One way is to group the measurements into classes of a frequency distribution, and then displaying the data in the form of a histogram. So there's optional reading on page 42 for a method of calculating the group sizings, but I think at this point we're just going to take the different group sizings for granted. So like if you noticed here on this histogram, the group sizings are between 10 and 13, 13 to 16, 16 to 19. So the group sizing is 3. But for quantitative data, just like we did for the qualitative data, we can make a frequency table and a percentage frequency table and a relative frequency table, and that's just shown here. So this class here is between 10 and 13. How many numbers in this table do we have that are between 10 and 13? And they're saying that there exists 3 numbers in that table. Okay, so here there's one of them. There's a 12, another 12, and a 10. Okay, and then we're on to dot plot. So this is also for quantitative data. Each dot signifies one instance of data. So, for instance, like say in a data set, this is the number 32. We have one instance of 32. This looks like a 45. We have one instance of 45. We go all the way over here. This looks like it's a 61. Okay, we have 2 instances of 61. 2 instances of 65 or something like that. These are dot plots. Probably not going to get into those too much, so that's why I'm not even really going to spend a lot of time on them. but they're also fairly self-explanatory. Stem and leaf plot kind of looks like a histogram or a bar graph that is turned on its side and made out of numbers. So right here we have this data set. So a sample of 50 mileages for a new mid-sized model of a car. Okay, so this is like my MPG, miles per gallon here. So this one is 30.8 miles per gallon. So essentially, the way that you make one of these stem and leaf plots is you take the whole number and all of the whole numbers that are in the data set. So this 30.8, the whole number is 30. This 31.7, the whole number is 31, and we list them right here. And so then for the 30.8, one of those resides here. So there's another 30.8. That's right here. And another 30.8. That's right here. So we would just put them in ascending order. So the decimals in ascending order after this line. So it's kind of a mix of, I mean, it just turns these numbers into a visual in and of themselves. And you may have seen this already as well. And 2.5, contingency tables. So this is going to be something that we are going to focus a lot on and we're going to use a lot in this class. So the main thing is that this classifies data in two dimensions. Rows classify one dimension, columns classify another dimension. So in columns right here, we're classifying the level of satisfaction. In the rows, we're classifying fund type. So bond fund, stock fund, tax deferred annuity. So this requires three variables: the row variable, the column variable, and the variable counted in the cells. Okay, so these are variables: high, medium, low. Those are variables. Bond fund, stock fund, tax deferred annuity. Those are variables. And then the variable of what is the number inside of these cells. The row totals provide a frequency distribution for the different fund types. So if we were to ignore all of the information right here and just look at this total, we see 30, 30, 40, and 100. So that would mean that there was 30 total bond funds, 30 total stock funds, and 40 total tax deferred annuities. We can do the exact same thing for level of satisfaction. We ignore all the stuff on the inside, and we can see that irregardless of this fund type, we know that there was 40 that were high level satisfaction, 40 that were medium level satisfaction, and 20 that were low level satisfaction. And then, yeah, this might be obvious, but the main purpose is to investigate the possible relationships between the variables. And this is just an introduction, so I'm not going to get into how we're going to analyze that or anything like that, but that is the overarching theme here. One way to investigate relationships is to compute row and column percentages. So right here we're looking at a row percentage, and this is essentially like the percentage frequency like that we just looked at. So if we're looking at bond fund, we have 15 divided by 30 gives us 50%. 12 divided by 30 gives us 40%, so on and so forth. And that's how you do that. So you just take the number that's in this cell divided by the row total. And you could do this similarly for the columns. And we're just going to talk about misleading graphs and charts. And this one is starting the vertical axis at 58,000 makes the increases in mean salary look more dramatic. When the vertical scale starts at 0, the increases in mean salary look less dramatic. You're just going to see that, like, you can play around with the design and the look of your graph, and you can make it visually tell a story that it might not numerically tell, right? Or it might not mean the same thing that it looks like it might mean. for instance, for this hospital administration, if like the average salary, if you expected the average salary to be 60,000 and you didn't expect it to go up from 60,000 at all, this might be a good looking graph because it's showing that actually, wow, it is moving up from 60,000 year over year. Okay, and if you were examining that exact same thing and looking at this graph, you might say, yeah, no, it's not really going up that much because it just doesn't look like it. But when you actually look at this and look at the numbers, oh well, there's a 60,000 increase to a 66,000 increase. That's 10% in 4 years. I mean, and that's up to you to determine if that's significant or not. You know, more misleading things. This is just changing the width to make something look more pronounced. So these are the exact same graph, except number 4 has a bigger width than this number 4. And I don't know, it kind of just makes it look a little bit maybe more of an outlier, or maybe more skewed to the left. But yeah, it's misleading, and it's just something that you have to look out for. That's that. So please let me know in the discussion if you have any questions about Chapter 2. Like I said, no review sheet, just kind of an intro to graphs and contingency tables. Hopefully you guys got that. There'll be a lot more on contingency tables in Chapter 4 when we go to use them for probability purposes. So like maybe if that wasn't that clear, I wouldn't worry about it that much. But if you do want to know, ask me questions in the discussion. You have your book, your ebook, you have the PowerPoints to look at. Yeah, there are definitely resources and the web as well. But yeah, thanks for, I guess, tuning in, guys. And yeah, Chapter 2, Dunskies. And yeah, on to Chapter 3. All right, take care.